So, welcome everybody. This is the third video I'm making for Algebra 2 here. And what I'm going to attempt to tackle in this video is this idea of the unit circle and how it can allow us to think about trig functions of any angle from 0 to 360 or even beyond. Maybe we'll get to that in this video, maybe not. But basically the unit circle has a few components, and it was created for this purpose of measuring trig functions. And basically, the basics of the unit circle is that it's on an xy coordinate plane, and that the radius of the circle, so from the circle to any of these outer edges, is 1 unit, hence the name unit circle. So this would be the point, because it's on the coordinate plane, 1, 0. This would be 0, 1. This would be negative 1, 0. And this would be 0, negative 1. Those are the basics of the unit circle. That's it. So you might say, Mr. Tannen, well, what is the use in that? Well, let me see if I can show you. So if I take a beautiful purple line to show something here, and let's say I'm trying to measure, for instance, I'm going to say I have this ray coming from the origin and passing through the edge of my circle here. Well, what the unit circle allows me to do is, if I thought about this as a triangle, right, with this angle here being theta, and of course this is a right angle triangle here, what it's going to allow me to do is think about the ratio of sine, cosine, and tangent with regard to this unit circle. Because if you think about it, I said that this circle has a radius of 1. So in this case, the hypotenuse is always 1. So the sine of theta, for instance, the sine of theta, in this case is just going to be the y value at this point, right? Because the y value is going to tell me this opposite height. And the x value, it'll just be the y value divided by 1, which is just the y value. The cosine measure is the adjacent, so adjacent to theta is just this side, which just so happens to be the x value at that point. So it'll just be x divided by the hypotenuse, which is the radius, which is 1, which is just x. And then the tangent is going to be the opposite over the adjacent, so it's just this y value over the x value. So what the unit circle allows me to do is give me a clear way to think about these different trigonometric ratios. For instance, if I ask for what the sine was of 0 radians, let me ask you this. What's the sine of 0 radians? Well, this is where I have 0 degrees. I haven't started rotating it all around the circle. So actually my y value is 0. Even though my x value is 1, if I do 0 over 1, my x value isn't 1, my hypotenuse is 1, sorry. 0 over 1 is still 0. If I did the cosine of 0 degrees, though, that's the adjacent over the hypotenuse. And if you imagine this is like a flat triangle, that's basically the adjacent and the hypotenuse are both 1. So the cos of 0 is 1. And if you do that in your calculator, cos of 0, you'll get 1. And the tan of 0, the tangent of 0, is going to be the y value of the x value. Well, we already said the y and x value, well, the x is 1, the y is 0, so this will be 0 over 1, which is also 0. So what the unit circle allows us to do is think about these trigonometric ratios in sort of a structured manner on a coordinate plane with the reference of a circle with a radius of 1. If we were to do, let me see if I can erase some of this here, some of this mumbo jumbo I got here now. Oopsies, what? Okay, that's okay, I guess. I might have to fill in my circle here with some red lines. That's good enough. But what if we thought about a line that were down here? I'm going to try to make this like almost perfectly through that fourth quadrant here. I would call this well, it could be a 45-degree angle, but if I go around this way, it'll be 90 plus 90 plus 90 plus 45. So I could talk about this either as a negative 45-degree angle or a positive 315-degree angle. Either way, what we notice is that, and what we know about this fourth quadrant is that there, well, if it's 45, the x and the y are the same, right? And it just so happens that you're going to sort of get used to this. The sine of, I should say, negative 45. Well, the x and y are the same distance, but in this case, the y is the x is positive because we've gone to the right, but the y is negative because the point is down in the fourth quadrant. So we get root 2 over 2, and then a negative root 2 over 2. Which is, if I find the sine, it's going to give me negative 1. The cos of negative 45 is also negative 1. Oopsie, scratch that. My mistake. The sine, I'm thinking of, I'm already jumping ahead to tangent. The sine of negative 45 or 315 degrees, they're actually the same if you do them in your calculator in degree mode, is going to be, in this case, the sine is the opposite, so that'll be a negative root 2 over 2. The cosine is a positive root 2 over 2, and then the tangent of negative 45 or 315 is going to be a negative 1. So what you notice is that because the y value is negative, the sine is negative, because the sine just is the y value. The cosine just is the x value, and the tangent is the ratio of the y value to the x value. So what the unit circle allows you to do is just think of the sine as the y value of a point on the unit circle, the cos as the x value, and the tangent as the ratio of the sine to the cosine or the y to the x. I hope that this was helpful. I'm also going to make another video on my laptop showing some things not written by hand, but just some interesting things on the TI calculator as well as on interactives online that I think may be helpful. Miss everybody. Hope you're doing well. Much love.